Well, thank you everyone for making it back from the break. The topic, the paper that I'm going to be talking about deals with process hazard analyses, but not applied out in the process plant, applied to a unit that everybody has but nobody pays much attention to in terms of process safety, the boiler house. See if we can get this moving. So the presentation is going to be broken down into a brief introduction, give you a little bit of a background on boiler systems and safety, talk about performing PHAs and a specific type of PHA on boiler systems. We're using a checklist process which works out very well for these types of units, and then give a couple of examples of modules that the checklist has been broken down into. So steam generation, everybody takes it for granted, but it's what keeps the chemical plant, keeps the refinery running. The steam plants, the boilers, are often the oldest unit on the plant grounds. They could have been built in the 50s, the 60s, the 70s, and they still keep running. Everybody relies on it. Because of the high temperature, high pressure steam involved, everybody's aware of that hazard, but there are also significant combustion safeguards with the firebox and burner systems. The process safety management objectives that you apply to the rest of the plant should still apply to the boiler house. So steam's been around for a long time. Steam's been harnessed for over 300 years until the form that we have it today, high pressure steam boilers, with an increase in complexity in boiler systems throughout the years. The increase in complexity of safety systems have come right along with that. As far as boiler guidelines that apply to boiler systems, you have ASME, Boiler and Pressure Vessel Code, that covers construction of the pressure parts. There is originally NBFU 60 was implemented to look at the operation, safe operation and control, and eventually that evolved and got wrapped into NFPA 85, Boiler and Combustion System Hazards Code, which is the workhorse for operation safety in boiler systems. So if you're going to do a PHA on a boiler system, there are many, many tools or techniques that you could pick from. You could do a HAZOP, you could do a what-if, fault tree analysis. One technique that we found to be especially useful because of the guidelines that are available is a checklist analysis. So why do we pick a checklist analysis? The answer is NFPA 85. 85 covers in detail and provides prescriptive guidelines for operation safety in many different areas that I'll discuss. 85 was established over 80 years ago, or at least the documents and the standards that feed into it. So as I said, it started in 1924 with the first formal code, and it's evolved into several other codes that were combined to form the current NFPA 85. And one of the big utilizations or big pluses for NFPA 85 is it provides explicit and prescriptive language about the safety systems and the safe operating practices that are necessary for a boiler. '85 not only covers one type of boiler, covers them all. Single burner, multiple boiler, heat recovery boilers, stoker boilers, pulverized coal boilers. It also lays out requirements for mechanical equipment, lays out requirements for fuel handling, although those are not as well defined as they could be, but it does provide some basics. It also provides very prescriptive guidelines for burner management systems. Combustion control systems are the other aspect of control for a boiler. The burner management system is what you use to start and stop the boiler. It's a safety system. Combustion control is how you speed it up and slow it down, and the combustion control should seamlessly interact with the BMS to trip the boiler offline if necessary. That's also covered in 85. There are also prescriptive guidelines on operation and training. It's an example of burner management system, a prescriptive requirement in 85. This is paraphrased a bit, but there are a series of individual trips that if any of these interlocks is tripped, it should lead to shutting down the boiler immediately. These are laid out very descriptively and precisely in 85. So it provides a good basis for creating a checklist. So creating a checklist seems like it should be very straightforward. However, it actually can be very cumbersome and complicated, and then managing that checklist introduces some problems. One of the keys for applying a checklist as a type of PHA to a boiler system is basing it on the prescriptive guidelines in 85. Another aspect that's important in developing that checklist and implementing it is to have a good organizational history or experience base of professionals who not only have used the standards, have operated the boiler, and have been in charge of maintenance, but can also communicate well and understand how to organize the information. And in many cases, you can't use one professional to create the checklist and maintain it. It requires many different disciplines. I should step back and say the authors on this paper, we've teamed up to work on this topic in several cases. I'm a chemical engineer. One of the other co-authors is a mechanical engineer, and then we have 2 electrical engineers. So it's a true multidisciplinary engineering team to try and address this issue of developing and implementing a checklist on boiler systems. Now, an example of a very simple checklist, which you can't really use, but this could be a starting point to make sure that you have at least the right categories of information and the categories of knowledge about the system. Could be trying to, organize the standards or subsystems of the boiler to make sure that they meet the relevant guidelines. So this is an example. This is like a summary or an executive summary spreadsheet or checklist sheet that could be used to apply to the overall PHA. We're checking to see if do we have safety interlocks? Do they meet the NFPA standards? What about our procedures? Are they accessible? Are they updatable? So the checklist process, we like to think of it as a life cycle. There are several steps when you start from scratch. There's the checklist development stage where we are creating our stack of books and standards and documents. And then there's the implementation stage where we've taken our already formed checklist now. We're going out into the plant. We're working with the plant engineers to try and check off the boxes and identify any areas where we need further improvement or capital investment. So the team members on that team, there may be different team members on the development side and the implementation side, but all the team members need to understand the technical requirements for the area that they're working on, and they need to understand the guidance documents that apply. So it's another reason that multidisciplinary teams are essential. As a chemical engineer, I can certainly understand the control aspects for the burner management system or for the combustion control system, but I'm not really that good at stepping through ladder logic. So I want to pull in an electrical engineer who's much more comfortable with that. So on the development side, first thing we have to do is decide the scope. Are we going to take NFPA 85, just translate it line for line into an Excel spreadsheet and go down and tick off the boxes? Or are we going to try and identify the main subsystems that we want to focus on and limit our checklist to a more select set of hazards? So then, like I said, you've got to go to the bookshelves, and you may have to go out into the literature and pull together the appropriate guidance documents so you can create your library that not only the current team, but the team in 4 years or 5 years can come back to, or the team when there's management of change issue can come back to, and they have those reference documents. They can take the checklist and compare it to the document on the shelf to understand why it reads the way it does. Then there's an analysis part where the team has to go through those documents and figure out whether they're really applicable. You know what? We've got a stoker boiler. We really don't need to pay much attention to the fuel gas section, so we can throw that out. But well, you know what? Sometimes we like those with portable gas igniters. Maybe we need to pull that back in. And then the key, which is really an organizational issue, personal organization, is combining those requirements into a usable format, a usable checklist. So now we have our checklist. And I've seen checklists that range from a page to 4,000 entries to cover this kind of process or similar processes. So first thing you have to do now is go out into the plant, grab the maintenance records, get the procedures, any other documentation, perform interviews that you may need to do to make a first pass through this checklist. Go through and enter that data. Has it been accomplished or hasn't it? There needs to be one or more managers of the checklist, and they need to control document revision history. You can't just let 10 people on a team willy-nilly go into a document that's on a shared drive and check some things, uncheck others, change the status of different items. There needs to be one manager who has that responsibility for that checklist. And then as you move forward in time, this is a living document. Requirements change. We have to update safety components. You may need to decide that, based on corporate policy, you need a SIL 2 system in one part of it. So you have to revise that checklist. It's a living document as you go forward in time. This is just a snippet of an example of a checklist. It's a simple checklist that can be a lot more complicated, but there are some features that are important as far as organization. A code or a guidance document reference is very important to have. That way, if you have a question about the relevance of that, you can go back to the original guidance document and see context, because this list may be collapsed. You may excerpt only a portion of this list for management or maintenance or some other use. There needs to be some easily understandable requirement that's expressed. So this can be copied, paraphrased, elaborated upon, whatever the case may be. There needs to be some sort of a status indication. I like to use simple wording and colors that make sense. Green means it's done, you're good to go. Red means no, it's not done. Yellow means we don't really know right now and we're working on it. Follow-up criteria, status date, completion date. You can have all kinds of follow-up criteria, comments, and it's important to have someone who's the owner for each individual item. And that's not just the newest guy on the block. It could be someone in a specific business unit, in a specific role. But the responsibility really needs to be spread out among those on the team and those who are pulled into the team effort. So in looking at a standard boiler system, there are 5 principal areas to consider for creating a checklist PHA. There's fuel handling, which can be quite complicated. Burner management system, which can be simple or complicated depending upon the size of the boiler unit and the type of fuel. Combustion controls, which again is coupled with the complexity of the overall controls in the plant and the units that are tied into it. Operations, so that includes procedures, management structure, interactions with other operating units, users of steam, and then training. So training not just for operators and their managers, but training for maintenance staff, instrumentation technicians. So to step into an example to talk about fuel handling. Fuel handling is an interesting topic, especially with all of the focus that's being placed on combustible dust hazards out in industry and through OSHA. So team members that we've often identified have to have expertise in various areas: controls, mechanical systems, mechanics, maybe even metallurgy, combustion systems, operations, maintenance, electrical engineers, controls engineers. There are a set of guidelines that apply mostly to handling the fuels, somewhat to the controls. The National Fuel Gas Code 54, NFPA 54, in concert with 85, applies to fuel gases. So if it's a propane-fired burner or igniter or a natural gas-fired burner or igniter. Fuel liquids, so fuel oil-fired burners are covered in NFPA 85. Then solid fuels, which is quite a wide range. There are combustible dust hazards. The list of NFPA standards here that I've included is pretty broad. There's work right now to come up with a more comprehensive NFPA standard to cover dust handling. But the question, I still have questions about how well that's going to apply to coal handling systems. There's an FM data sheet out there. So the primary hazards with the combustible fuels or solid fuels, such as coal or Western coal that can self-heat, we have combustible dust hazards and we have self-heating hazards that have to be considered not only from the coal dump but all the way up to introducing that fuel into the boiler. Another area to focus, BMS and burner management system and combustion control. These are often confused. Burner management system, here's the detailed definition from NFPA 85. It's combustion safety and operator assistance in starting and stopping of fuel preparation and burning equipment for preventing misoperation and damage to fuel preparation and burning equipment. Basically, this is the safety control system that keeps you from blowing up the firebox. So you want to safely start up and introduce fuel and safely purge after you shut down. That's what the BMS is there for. The CCS, this regulates the furnace fuel and air inputs so that you can maintain those inputs within required operating limits and try and eliminate hazardous states. So you're not going to send the boiler into a dangerous spot. There are guidance documents out there which can also be wrapped in to the control side on the combustion control checklist requirements. And somewhat on the BMS, there's ISA 84, because the BMS is ultimately a safety instrumented system. ISA 77 and ABMA combustion control guidelines that talk about controls, design, and implementation for boiler systems. Operations and training. One of the benefits that we've found from creating checklists like this, going out into the boiler house and using them, is that it helps facilitate training for staff and understanding the hazards. So as any PHA, it requires you must have good, understandable, well-defined procedures. So that's a requirement. There needs to be a periodic review and update of those procedures, and having the checklist helps because there are specific requirements that can be wrapped into a checklist for procedures. Having the checklist also helps you retrain operators on changes to those procedures. But ultimately, keeping the procedures up to date requires time and money and investment that's difficult to get, especially in the boiler house. So it seems really easy when you talk about it in the abstract to apply a checklist to a boiler system. But when you start to dive into it, you see that there are some confusing and contradictory requirements. Because if you stick by one standard, 85, you can put together a checklist very well. But if you start to broaden that to other aspects of the industry, you have to of guidance documents, you have to figure out how they relate to each other and make a decision on which one takes precedence. So in conclusion, it's a fallacy to think that in any PHA you could be 100% comprehensive. Checklist is the same way, so you have to establish how detailed, how complicated do we want it to be. And we found with checklists, even very short ones sometimes, it's difficult to get those things 100% punched out. So checklist is an excellent tool when you have to manage multiple guidance documents to apply them to a process unit, when you want to identify deficiencies in that unit against those standards, and also to help familiarize personnel with boiler systems operations. Good training tool. We've also found that it's helpful to create a checklist that a company can then turn into a company-wide standard or guideline for safely operating and maintaining boilers. So with that, are there any questions? Very good. Thank you.